Good. Thanks everybody for attending today's webinar on manufactured stone veneer, design, installation, and maintenance with our design studio manager, Jeff Charles. My name is Brian Yansak, and I am the design studio and events coordinator for Glen-Gery. During the presentation, you will notice the Q&A function at the bottom of your screen. Please feel free to submit any questions throughout the presentation, and they will be answered at its conclusion. Your attendance will be marked, and we ask that you stay on for the duration of the presentation to receive credit. Everyone attending the duration of the course will be receiving a certificate of completion by the end of the week, and those who provided their AIA number during registration will be submitted for credit as well. If you're participating today but did not register and wish to receive AIA credit, please email events@glengery.com, that is events@glengery.com, with your information, and I'll be happy to make that happen for you. Today's session will also be recorded, and a link for you to access it will be provided within your certificate of completion. I would now like to introduce our speaker today, Jeff Charles. Jeff has over a decade of experience within the construction industry, both in the field and in sales management roles. Jeff began his career as project manager for a commercial concrete contractor. He then went on to management roles within the manufactured stone and brick industry, and has experience managing commercial masonry projects throughout the East Coast and Canada. Jeff also has extensive experience assisting architects and designers with material specifications on large-scale projects in both the public and private sectors. And with that, I'll turn it over to you, Jeff.
Thank you, Brian. Very kind introduction. I hope everybody is doing well today. As Brian mentioned, this seminar is going to cover manufactured stone veneer. But before we get into the AIA portion of the program, I just want to go over a little bit about Glen-Gery and what we do specifically. So Glen-Gery itself was founded in 1890, just outside of Reading, Pennsylvania. We're a very old brick manufacturer, and we're one of the largest brick manufacturers in the United States. In 2018, we were acquired by an Australian building materials conglomerate called Brickworks. Brickworks produces everything from roof tiles to precast concrete to timber to, of course, brick. We were their first overseas venture. Upon acquiring Glen-Gery, they also acquired several other brick manufacturers in the continental United States. These include Sioux City Brick and Redland Brick as well. This map is just a little bit of an overview of our footprint as a company. You'll see our headquarters here, located just outside of Reading, Pennsylvania, in a little place called Wyomissing. As you can see, we have several direct sales locations located throughout the East Coast and the Midwest, and our stone manufacturing plant is located right here in Cynthiana, Kentucky. Some of the things that we sort of specialize in and try to differentiate ourselves from other manufacturers is we offer imported products like Venetian glass brick, as well as brick imported from different manufacturers throughout the world. We also specialize in coated brick. Going with a coated brick allows us to achieve colors that are not normally possible with traditional raw material deposits. So it allows us to produce really interesting gray ranges like this. We can produce blues, greens. We can even do yellow bricks. We also manufacture handmade brick. We're one of the largest producers of handmade brick in the United States. And when I say handmade, I do mean handmade. I'm sure everybody saw the commercial prior to the beginning of this seminar. We are literally producing brick in the same fashion that it was produced thousands of years ago by physically taking raw material and placing it by hand into wooden mold boxes. So it gives a really nice kind of old world traditional appearance to the units themselves. We also specialize in making what I would consider sort of non-traditional brick products. What you're looking at here is a product we make called Roman Maximus. This is a 2-foot long brick. Really lends itself well to creating sort of a sleek modern profile for any project that it's incorporated into, and is available in a variety of different colors and a few different textures as well. We also manufacture pavers. There are a number of advantages to going with paver, clay pavers specifically over cementitious pavers. much more resistant to freeze-thaw cycles, and they maintain their color far longer than any cement-based product on the market. Finally, we have our Feldhaus line. Feldhaus is actually a newer product for Glen-Gery. Feldhaus is a line of German manufactured imported thin brick, specifically geared towards precast concrete construction. All of these units come in PCI compliant and are available in an incredibly broad spectrum of colors, textures, and sizes. All that being said, we also try to position ourselves within the industry as a resource for the design community. In addition to all the different types of products we offer, we do things like product and technical profiles, case studies, AIA presentations like the one you're all attending today, as well as specification and detail reviews at no charge. So all that being said, I'm just going to get into the AIA portion of this presentation. This is registered with AIA for a continuing education credit, as well as an HSW credit. I will do my best not to talk too long and keep this to as closely an hour in length as possible. So these are just a few basic resources that you can reference in addition to this presentation if you're curious about in learning more about the topic itself. One of the best ones here is the MVMA installation and detailing options for compliance with ASTM C1780. The MVMA is the Masonry Veneer Manufacturers Association, so this is a very, very helpful resource sort of written by the people who are actually manufacturing these types of products. These are just a few of our learning objectives for today. Obviously, we're going to review some of the steps used to make manufactured stone. We're going to look at some of the basic recommended installation practices. We're going to look at ways to specify appropriate cleaning procedures. And we're going to look at ways to select appropriate units to maximize durability and minimize life cycle costs. Now, how is manufactured stone made? Obviously, this is a cement-based product, so there are a few different things that go into making the units themselves. Of course, we have cement, we have sand, we have various color agents, and the big thing I want to touch on in this slide is lightweight aggregate, and that word lightweight will become very important later on, and you'll find out why. So when we talk about aggregates for manufactured stone veneer products, we're looking at a certain lane of aggregates in that they have to be very lightweight. So we look at things like expanded clay, shale, sand, things of that nature. And these are incorporated into large aggregate storage bins. These are generally housed on site at a manufacturing facility. You can see a better picture here in this next slide. Obviously, these are very large containers holding lots and lots of material, tons of material at a time. So what we do is we take aggregate from those storage bins, and generally that is combined with cement and fed to our overall mixing operation via some sort of flex wall conveyor. There are a few different versions of that, as you can see here in these slides. So what we do initially is, aside from adding colors to the face of the stone, we actually add color to the integral cement mix itself. So this is generally regulated through automation, and we can control the specific proportions of water, the specific proportions of aggregate, color, that sort of thing, so we can really dial in the appropriate mix depending on what specific product is being manufactured at that time. Now, how we make manufactured stone is we're literally taking cement mix and adding it to different types of pre-designed molds. Now, these molds can be made from a variety of different materials, including latex and urethane. And the material that the mold is made from can really affect how detailed of a face profile we're able to achieve on the units themselves. So, for example, something like latex is generally used if we're looking to create a very, very detailed face profile. These veneer molds are loaded onto rollers and they're misted with water. Now, this is the first step in making any kind of manufactured stone veneer product. And the reason why we mist the molds prior to anything else being done is we want to enhance the color dispersion later on. We don't want too much color in one area of the unit. We want the color to be naturally sort of dispersed throughout the face of the unit. We then take our finished mix from that large mixing operation that I showed you earlier, and we transport that to stands which sit over top of vibrating tables. We then add iron oxide tints or other different mineral-based color pigments to the molds themselves. And again, this is where that pre-misting comes into play. If you'll take a look at this slide in the bottom right, you'll see that the water allows those pigment colors to evenly disperse throughout the face of the unit. We don't have too much black in one area. We don't have too much brown. It's sort of all naturally intermingled together. We then take our cement mix and add it to our molds. These molds, as they're being filled with cement, are of course sitting on those vibrating tables that I mentioned earlier. Now, the reason behind these vibrating tables is they, of course, alleviate any air pockets within the units themselves. We don't want a bunch of units with what I would commonly refer to as bug holes in them going out and ending up on a job site. They then scrape off the excess material, and that's actually reincorporated back into the original cement mix for further use. We then pull the molds, palletize them, and transfer them to drying stations where they're allowed to dry for about 24 hours before they're stripped from the molds. Stripping is actually one of the most labor-intensive parts of the entire manufacturing process because generally it's done by hand. So these molds are carefully stripped, and we then package the units into their appropriate packaging. Now that we've covered the basics of how these units themselves are made and what they're made of, I'm just going to touch on some of the very common manufactured stone profiles that you might encounter out in the field. So what we're looking at here in this next slide is field stone. Now, one thing that you'll notice here is no two units in this photo are the same. This is meant to replicate the look of naturally quarried, uncut stone. So it's going to be a variety of shapes, sizes, and even textures made to look like something very, very natural, something that has not been interfered with too much by the hands of man. We then move on to what's commonly referred to in the industry as a cobblestone profile. I'll hear it called ashlar. It's generally just a assortment of varying sizes of squares and rectangular units that lends itself well to a more traditional sort of colonial look. And then, of course, we have ledge stone. Now, I like this photo a lot because this is a really, really nice ledge stone installation. You'll notice that all these units fit together very precisely, and we don't have a lot of gaps. Now, what ledge stone generally consists of is longer, but still irregular pieces of stone that all fit together very intricately. And one thing you'll notice that's different in this slide from the previous slide is we have no mortar joints between these units. This is what's commonly referred to within the industry as a dry stack application. There are no mortar joints between the pieces of stone themselves. We also have specialty profiles. What you're looking at here is, certainly not made to look like stone per se, but it is a cementitious product, and it does still fall into the same type of masonry veneer category as manufactured stone. So you can see that in units like these, we have very, very, very detailed face profiles. We have grain, we have knots, and then commonly what you'll see with units like these is they actually have finished ends. So there really are no corner pieces. You simply butt units like this up against each other because they actually have a finished texture on the ends of them. Finally, and this is probably one of the more common profiles for commercial applications, is we have panelized manufactured stone. Now, you'll notice this is a similar application to this slide in that it's a dry stack application. But the difference here is these are actually larger pieces of manufactured stone that all intricately fit together to look like they are comprised of many, many smaller units. So whereas it takes a lot of skill to properly install ledge stone in a dry stack application and make all these tiny little pieces fit together perfectly, these panelized options allow us to create that look, and it's much, much simpler to install. So those are just a few of the common profiles. This is not certainly all of them by any means, but these are some of the more common ones you may encounter if you're looking at any type of manufacturer's product line. Now we're going to go into a little bit about how manufactured stone itself is installed. I'm going to cover some various methods as well as some sort of best practice, procedures that you can include into specifications and things like that. Manufactured stone is basically governed by two clearly defined installation methods, and that's the thick set method and the thin set method. So first I'm going to cover the thick set method, and then we'll get into the thin set method. The thick set method is probably one of the more common types of applications, and it's generally in a lot of cases geared towards residential construction. So when we talk about masonry veneer, this can be brick, this can be stone, this can be CMU. We break it down into two sort of subcategories. We're not building a mass masonry wall here. We're using masonry as a veneer. So the International Building Code defines masonry veneer two ways. There's what's known as anchored, and again, this can be brick, concrete, natural stone, and adhered. And this is generally what manufactured stone and thin brick products fall into. And you'll notice two key differences here. The weight. So the weight of anchored veneer is much heavier than what would be considered adhered veneer. You'll see a max of 40 pounds per square foot for anchored and a max of 15 pounds per square foot for adhered. This is because of how these units are actually installed. So anything that's considered anchored veneer is secured with approved mechanical fasteners back to some sort of substructure, whereas adhered veneer is supported through adhesion of some sort. It's adhered to the structure through the use of some sort of mortar or various other fastening and adhesive systems. These are just a few installation standards that you can reference. Obviously, one of my favorites here is the Masonry Veneer Manufacturers Association Installation Guide. This has a lot more detail on a few of the things I'm about to cover in the next few slides. So first we'll get into thickset installation, and there are sort of two subset categories for thickset installation itself. There's what's known as direct mortar setup, which generally centers around a masonry backup of some kind. Think about a poured concrete wall, a precast concrete wall, or a block concrete wall. A couple things to make note is that depending on how level the substrate is, sometimes you'll be required to put a skim coat over top of that so that you have a nice level plane to install your units themselves. Another key takeaway when you're looking at doing a direct mortar set application is that the surface itself must be clean and uncoated. If you have a painted concrete wall, it's definitely recommended that you take additional steps to ensure that the units themselves can get a sufficient amount of bond. And then we have what's known as, or commonly referred to as, scratch and lath. I hear it said a bunch of different ways, but it's still considered this thickset installation method. This centers around installing metal lath over your substrate, and it's generally used on stud wall assemblies, steel stud, wood stud, things of that nature. And it incorporates wire lath and a scratch coat, but it can also be done over these coated masonry walls that we discussed just a minute ago. So if you have a painted concrete wall, for example, you may want to consider installing wire lath over it, which will help you to get your units themselves to bond to that, because you can lay a scratch coat over top of that coated masonry wall. So these are just some of the essential components for thickset installation systems. Obviously, we have our substrate. We have our water-resistant barrier, or WRB, as I'm going to refer to it, which is very, very important component of this system. We have fasteners, depending on whether or not we're using any kind of wire lath. We have our wire lath itself, which always, I cannot stress this enough, always make sure you are specifying what is known as self-furring metal lath. So when I say self-furring metal lath, this is what I'm talking about. You'll notice that this piece of metal lath, commonly these sheets of metal lath measure about 2 feet by 8 feet long. They're galvanized, and you'll notice here on the metal lath itself, we have these small sort of dimples that kind of stick out. Now, there is a very, very good reason behind the metal lath itself having these dimples. So what that does is it actually holds the sheets of metal lath just slightly off the wall so that they're incorporated into the scratch coat rather than being at the back of the scratch coat. This provides additional reinforcement for your scratch coat layer. So think of it in terms of a concrete sidewalk being laid. You don't want your rebar laying at the bottom of your concrete sidewalk because essentially it's really doing nothing for you. It's not providing any additional reinforcement. You want it incorporated into the middle of the slab of concrete so that it provides that additional reinforcement that it's intended for. So here we have a really nice detail on thickset installation over a masonry backup. Now, you'll notice a few things in this slide, in that in this case, we've opted to actually install metal lath over top of our concrete block. So what you want to do when you're specifying any sort of assembly like this is make sure that you're utilizing the proper type of fastener. So for masonry wall installation applications, we generally use some sort of gas actuated fastener system. So this is things like TrackFast or various other products where they're actually firing these fasteners into the concrete blocks themselves. I don't recommend installing wire lath over a masonry wall with simple spud nails or any sort of concrete nails. It really is best to use something similar to a TrackFast in that you'll notice here they incorporate a washer. This prevents the fastener itself from actually pulling through the wire and gives you a much more secure fastening to the backup itself. You'll notice in the next few slides here, the proper spacing for these fasteners is 6 inches on center for wire lath. And you'll look here at the bottom, you'll see that we have a weep screed. In the case of a masonry wall backup, this is optional. We do recommend it, but it is optional. But you also want to make sure that you're extending your masonry veneer at least 1 inch past the foundation that the substrate is resting on. So you'll see here we have our masonry backup, our wire lath with our fasteners 6 inches on center, our scratch coat, our setting bed, and finally our units themselves. Now, when you're installing metal lath onto any kind of substrate, we like to see at least 1 inch of overlap between the sheets of metal lath, both vertically and horizontally. And when you're wrapping a corner, we like to see at least 16 inches of overlap in those applications. So very important to keep those things in mind. We want a nice cohesive underlayment system, and you want to make sure that you're definitely overlapping all of that wire lath. Now, what you see here in this next slide is a bit of a breakdown of this thickset underlayment process. So think of this as a 4x4 area. Now, in this case, we've gone to what appears to be a stud assembly because you'll notice that black tar paper. So that's actually acting as our WRB in this case, which I'll get into in the next slide. So we have our fasteners 6 inches on center. We have nice overlap between our sheets of wire lath. We're then going to go ahead and apply our scratch coat. And then what you'll see in this next slide is why it's actually called a scratch coat. Now, this is another detail that I cannot stress enough. You need to actually scratch the scratch coat. They need to actually put those rake marks in the scratch coat itself, because what happens in the next slide is you'll see this gentleman here is back buttering his units to adhere them to his dried scratch coat. What happens is the mortar that you place on the back of these units actually interfaces with the grooves in the scratch coat and gives you a much, much stronger bond to your scratch coat and furthermore your substrate. So very, very key detail, very commonly overlooked in the field. So definitely make sure if you're specifying, installation practices that you call out that the scratch coat actually be scratched. Now this brings us on to thickset installation over a stud assembly. Now you'll notice here we've gone to wood studs, so we need to be much more cautious about detailing for preventing any kind of moisture from making it back to our substrate. So you'll see here we have our metal lath, of course. We still are incorporating those fasteners with washers so that they don't pull through the wire lath itself. Now in this case, your weep screed is no longer optional. It's a requirement for code. So very, very important that you're including a weep screed in any sort of detail that you're working up. And you'll notice here at the base, notice that the WRB itself overlaps the weep screed, not the other way around. That is another very commonly overlooked and extremely detrimental, if not properly installed, detail. So what happens is if this WRB is behind the top of the weep screed itself, what happens is any moisture that makes its way back to this WRB will be able to run down behind our weep screed instead of exiting the wall harmlessly, and it can make its way back to our sill plate and cause a lot of issues. So definitely make sure that the WRB is always overlapping the weep screed, not the other way around. Now, WRB, or water resistant barrier, as I mentioned earlier, is a very, very essential component of this system. And you'll notice that we have incorporated 2 layers in this assembly. 2 layers is code. Now, these 2 layers can be a variety of different products. Tyvek counts as one of these layers. So if you're working on a project where the framing contractor, it's part of his scope of work to install 1 layer of Tyvek over top of his work, you just knocked out 1 layer of your WRB. So your masonry contractor who's installing your thin masonry veneer over top of that only has to install 1 additional layer. But I do want to touch on water resistant barrier a little bit more. So the idea behind having a water resistant barrier is it protects the sheathing from liquid water, whatever that sheathing may be. Now, these water resistant barriers in a lot of cases can be air permeable or impermeable. So there's a few different types of water resistant barriers on the market. These can be things like polymeric membranes, i.e. Tyvek that you see in this photo. They can be self-adhered membranes like Blueskin, or they can be fluid applied membranes. A manufacturer by the name of Latacrete makes a very nice fluid applied air and water barrier for use on commercial and residential applications. If I'm talking best practices here, I like to see the latter before the former, especially on commercial projects. So self-adhered membranes, fluid applied membranes, they really do perform much better. If you look at the top slide here, think about how Tyvek is installed. We have a product that's designed to essentially create a shell around a building, and then you're going to go poke a bunch of holes in it because of how you have to fasten it back to your substrate. You're gonna use nails, you're gonna use staples. So in a way, you're compromising that cohesive barrier over top of your substrate. Another thing I commonly see, and I'm sure a lot of people who are listening right now have seen this, they've driven past a project that's partially under construction, and you see the Tyvek kind of flapping in the wind. It's not as controlled of an installation as you get with these self-adhered systems and these fluid applied systems. So not a requirement, just a recommendation. If you're looking at a commercial project, you may want to consider going for something more along the lines of a fluid applied or self-adhered membrane. Now I'm going to touch on some of the different qualifications for mortar and what types of mortar you may or may not want to use depending on the type of application you're working on. So you'll see here, these are just some of the basic requirements for mortar for the setting beds, for dry set cement mortars. And commonly what you'll want to use for pointing is definitely a type S mortar. And when I say pointing, that means after you've adhered your units to your scratch code or your backup or your substrate or what have you, that is the mortar that you actually come back and squeeze bag into the joints in between the units if you're doing an application that incorporates mortar joints. Now you'll see here for that dry stack installation that I touched on earlier, it is required that you utilize a polymer modified mortar for these types of installations. Now, when I say a polymer modified mortar, I mean a mortar that has a chemical additive that increases drastically its adhesive properties. So when you're talking about installing units in a dry stack orientation, you're essentially relying only on the mortar that is on the back of that unit to hold that unit in place on your wall. Whereas if we are doing an installation that incorporates mortar joints between the units, we have that additional sort of secondary attachment in that the mortar joints themselves knit all the units together. So it is definitely required that we go with a polymer modified mortar when we're not using mortar joints in the type of application. You don't want to see units popping off. I see it all the time on a lot of buildings that do dry stack applications. I'm sure a lot of people on this seminar right now have. They just sort of basically lose their bond. And when you go with a polymer modified mortar, you're not going to have that problem. And a lot of these polymer modified mortar manufacturers will actually warranty an installation if you use all the components of their specific system. And I'll get into that a little bit more in the next few slides here. So now this is a good segue into thin set installation itself. Now, thin set installation centers around these types of polymer modified mortars that I touched on in the previous slide. Now, the key takeaway here is we're basically replacing our scratch coat and metal lath with cement board and polymer modified mortar. So this is a really good detail for using the thin set method over a wood stud assembly. So there's a few key takeaways that you want to look at in this photo. And of course, we have a dry stack application in this particular detail. So you'll see your wood substrate in the back here. This is some sort of plywood structural sheathing, something along those lines. We have a layer of WRB over top of that. In this case, it's felt paper. We've then fastened our cement board over top of that through the stud assembly, and we've lap taped the joints in between the cement board panels. We then apply a fluid air and water barrier over top of our cement board. Now, it's very important when you're considering any type of polymer modified mortar that you look into compatibility with the air and water barrier you're planning on specifying. So I'm going to use Latacrete as another example because they're one of the bigger manufacturers out there. They manufacture their own air and water barrier that is compatible with their polymer modified mortar. So always take into account compatibility. So you'll notice, just kind of working our way from the back here, we have our cement board, our fluid applied air and water barrier, which has been rolled onto the cement board itself, our bond coat, which has been notched with a 3/8 inch trowel, and finally our units at the outside of the wall. Similar type of install, except now we're doing this over a masonry backup. So we have our masonry substrate here. And in this case, to create a more level surface and alleviate some of the depressions from the joints in between the blocks themselves, we've done a skim coat over top of that. We then apply that same fluid air and water barrier, our bond coat, and again, our units. Now, a lot of these polymer modified mortar products actually got their start from sort of flat work applications, like installing floor tile. I'm not sure how familiar everybody is with this, but floor tile, you're basically doing the same thing. You're installing cement board on over top of your floor substrate. You're then applying the polymer modified mortar, and you're taking a 3/8 inch notch trowel per manufacturer specifications here, and creating your bond coat itself. So all we're doing here is that same process, but we've applied it to a vertical application. And these systems, as I mentioned, are often warranted by the manufacturer, but they do require that you utilize all of the components of the system itself and source them only from them. Now, one of the best parts about using any kind of thin adhered masonry is it's very easy to design projects that also incorporate continuous insulation. Now, there's just a few key considerations that you want to look into before specifying any type of product and before working up any kind of wall section detail. We want to make sure that we're marking our stud locations, and of course, we may need to adjust our fastener length to accommodate the thickness of the type of insulation we plan on using. So here we have a really common assembly using the thin set method with a masonry backing. So what you'll see here is we have our masonry units themselves. In this case, it's CMU. We have a water-resistive barrier over top of that CMU product there. Then we have our rigid insulation. In this case, it's blue board, looks to be XPS in my opinion. We have Z-girts located in between the sheets of insulation to act as vertical support and assist with fastening the cement board through the insulation itself. So our cement board is actually fastened to these Z-girts. We then apply our setting bed over top of that, our bond coat, and finally our units themselves. So it's really, really simple assembly here. We're kind of just working out the different layers and bringing everything to the face of our units themselves. Now, getting away from the thin set method, there are also a number of ways you can do the thick set method over top of continuous insulation. So if you look at this detail here, we have in this case a steel stud wall. We have an exterior sheathing product. This to me, we'll say this is something comparable to the zip wall system that I see a lot. Then we have a WRB that's approved for use with the zip wall system. We have our rigid insulation, which again, in this case, appears to be some sort of XPS insulation. Then we're incorporating drain mat. Now, drain mat, in this case, actually replaces a layer of WRB. So per code requirements, you can actually substitute a layer of WRB for drainage mats. So you'll notice in this case, we have our one layer of WRB here, and then we have our drainage mat. So no further WRB is required. So what we're doing with that drainage mat material is it's manufactured through a variety of different processes, but the most common assembly I see is some sort of PVC derived mesh that has essentially a felt coating over top of it. Now what this does is it basically creates a cavity behind your manufactured stone veneer units, similar to the type of cavity, drainage cavity rather, that you would have when you're utilizing brick units and doing cavity wall construction. So this drainage material allows any water that makes it past our units and through our bond coat itself to flow harmlessly through that material and out at the base of our wall here. Now, what you'll notice in this photo on the left is that most of these drain mat material manufacturers will actually incorporate a protective layer of felt over top of the drainage material that is water permeable but does not allow the mortar to penetrate through. So this prevents your mortar from blocking up your cavity drainage material. And you'll see here, then we are attaching our scratch coat, or furthermore, our wire lath over top of that. Then we're putting our scratch coat, and finally our units themselves. So there's a few different ways you can go about designing a thin adhered masonry veneer wall while still maintaining continuous insulation. And there are even ways to create a drainable wall assembly, as you see in this slide here. Now I'm just going to get into a few really basic sort of best practice details for using any kind of manufactured stone veneer units. One thing you want to make sure is that you're definitely taking your units themselves at least 1 inch below the top of the foundation. And you'll see here, this is essentially that detail, that stud assembly detail that we looked at before. You'll notice we have our WRB overlapping our weep screed at the base of the wall, and we're taking that veneer 1 inch below the foundation, which is right here. Now, there are a few minimum clearances you want to observe. If we're talking about dirt, soil, a planting bed, something of that nature, we want to make sure we're staying at least 4 inches above that, 2 inches above paving, and a ½ inch above any kind of walking surfaces supported on the same wall. So very important that you make sure you observe these minimum clearances. This prevents moisture from wicking up into the units and prevents staining and helps prevent efflorescence actually. So now we're moving into sort of a top of the wall kind of coping detail here. And you'll see we have a manufactured stone veneer cap piece actually in this detail. Now, a couple key things to consider is A, we have a nice overhang here. We have at least 1 inch of overhang. So this unit itself will actually shed water both this way and this way. And as that water runs off the face of it, it runs down proud of the stone veneer below it. Now you'll notice this little detail, sometimes referred to as a kerf, sometimes referred to as a drip cut. Now what this actually does is it breaks that capillary action of that water inherently has that allows it to defy gravity in some cases. So without this little cut here, water can actually flow down the face of this cap and actually defy gravity right here, run underneath and begin to run down our units. That's going to cause staining, that's going to cause efflorescence, and it can potentially lead to deterioration in extreme cases. So very, very important, commonly overlooked detail. Always specify that any manufactured stone veneer cap pieces, when used in this type of application, incorporate a drip cut where they overhang the stone veneer. You'll also notice in this photo that we've gone to a soft joint at the transition between the top of the wall and the stone veneer itself. I always recommend a soft joint in these locations, and we want to make sure that we have closed cell backer rod and that we're sealing that joint with some sort of urethane-based UV resistant sealing. Another really important detail in any type of top of wall assembly, and this is true for cavity wall construction as well as thin veneer construction, always make sure that you're extending your flashing up over the top of this wall. Similar detail here, except now we've gone to a metal cap. Again, we have plenty of overhang here and a soft joint at the transition. Now we'll go into sort of window details. Window details are very, very important when using any type of masonry product, and manufactured stone veneer is no different. A few key takeaways from this specific detail is you want to make sure, again, we're overlapping our WRB and we're actually installing a weep screed above the top of that window. So that will allow any moisture that's running down behind the units above the window to drain harmlessly and not make its way back into our window assembly here. So very, very key detail there, weep screed above windows. And again, we have that nice soft joint at the transition between the weep screed and the window itself. Now, this detail here is the bottom of the window. So in this case, we don't have to install a weep screed, but we do want to make sure that we're taking our sill flashing underneath the window and overlapping it into our over top of our WRB that's behind our manufactured stone units. So that's a very, very key detail. Windows are one of the, I used to, in my previous life, do a lot of leak investigations related to manufactured stone installs. One of the most common places that we saw leaks was at window locations, and it was simply a matter of them not being flashed properly. So always, always, always make sure you are lapping your sill flashing over top of your WRB for your manufactured stone. And then again, can't stress this enough, soft joint. Any type of dissimilar material where it's meeting a masonry product, and again, this is something that's true of both cavity wall construction and thin veneer construction, always, always, always soft joint. Now, this is an interesting detail, and this is one that I think a lot of people don't necessarily consider. So when I used to perform leak investigations, water basically follows the law of gravity. It travels, it starts up high and it travels downward. So a lot of issues began higher up most of the time. So what you're looking at in this photo here is what's known as roofing lap kickout flashing. So what you see here is we want to incorporate this unit can be made out of PVC. I've seen them made out of metal. There's a bunch of different materials, but essentially we want to install a flanged piece right here that as the water travels down this roof line, it makes its way into this, I apologize, makes its way into this gutter assembly here so that it's properly drained away from our building. So say in a hypothetical scenario, we have stone veneer installed here and we don't have this kickout flashing here. All of the stone veneer that's below this roof line, water is going to travel down the face of that roof line. And in a lot of cases, depending on how heavy it's raining, it can actually basically overshoot this gutter. and then it begins to run down the face of your stone veneer itself. I see it all the time in buildings. You'll notice that a lot of inside corners, it's all stained up. You'll have moss growing, you'll have efflorescence, and you'll have deterioration in extreme instances. This kickout flashing prevents that from happening. As the water travels down, it hits this wall, and it's properly directed in our gutters where it's dealt with. Movement joints, this kind of touches upon some of the stuff I talked about in the previous detail. Obviously, we want to do this at any type of floor line. Big thing to take away from this particular slide, intersection of any kind of dissimilar materials, windows, doors, any kind of penetrations, if we're doing dryer vents, HVAC penetrations, all that sort of thing. Anytime you have that meeting with any kind of masonry product, you always want to make sure you have a soft joint in that location. And you generally want to observe a clearance of at least 3/8 of an inch between these dissimilar materials. So now that we've talked about some of the proper ways to install manufactured stone veneer, let's get into some of the different ways to properly clean and maintain your stone veneer product. We want the stuff to look as beautiful as the day it was installed years later, so there are some definite recommendations on how to properly clean. And some of this applies to newly installed units, and some of this applies to units that have been installed for a number of years. It really just kind of depends. And you should also always consult the specific manufacturer that you source the product from and get their specific cleaning recommendations. But a couple general rules of thumb when cleaning any type of manufactured stone veneer product is, bear in mind, this is made of cement. So it's vulnerable to all the same types of things that any cement-based product is vulnerable to, specifically acidic cleaners, metal scrapers, things like that. You don't want to damage your units while you're trying to clean them, because you're kind of going to go from the frying pan to the fire, so to speak. So acid-based cleaners can not only deteriorate the face, at the very least they'll remove the color. You never want to be scraping at anything, because essentially a lot of the color on a manufactured stone veneer unit is localized to the face of the unit itself. If you scrape off the color on the face, it's not going to look the same in the integral body color. We recommend for new installation that you use a clean, wet sponge within 4 hours to remove any sort of excess grout or anything like that. After 48 hours, we recommend a mild solution of water and trisodium phosphate. And then really important thing to always consider when you're cleaning any type of masonry product. Again, full bed depth brick, CMU, limestone, anything. Always do a test area. If you have extra pieces of the material that aren't installed on the wall, do it on that. Or I would recommend doing the test area on some sort of location that is not easily noticeable, because you never really know specifically how these products are going to react. Even if you're following the manufacturer's instructions to a T, perhaps the material was installed in such a way that it's altered the composition slightly. So I always recommend that you do a test area before doing any large-scale cleaning process. Guys, this really does conclude the AIA portion of the program. At this point, I will field any questions you might have, and I thank everybody so much for taking the time to attend today.
Looks like we had some questions, Jeff.
Sure. Let me just get back in. Okay, top of the list, TKS Architects, I miss you guys too. I hope you guys are all doing well. Anonymous attendee, is flashing typically used in addition to a weep screed, or is it just the weep screed? Always flashing over top of the weep screed. In some cases for residential applications, you can get away with simply lapping your WRB over top of your weep screed. But if it's a commercial wall assembly, it's just kind of one of those things, belts and suspenders. You may also want to consider doing flashing at the transition area. And there are various self-adhered flashing materials that can be used that will actually stick to the WRB and lap over top of the weep screed itself. So it really just depends on the wall assembly. It's not required, but you know, it's one of those things that just kind of belts and suspenders, it can't hurt. Do you have a detail for the base of the wall where there is exterior paving up against the building? So in that type of application, you may want to consider utilizing some sort of additional, and I'm at the question here where we how to terminate above paving. This is one of the ones that's really a sticking point. People hate that look of, you know, the stones sort of stopping and not running all the way to the dirt or all the way down to the paving. What you may want to consider utilizing in that type of application is going over top of your sheathing with some sort of, not sacrificial material, but a material that is suitable to be installed at grade and, you know, is visually complementary to the stone itself. What I commonly see in these types of applications is various CMU manufacturers make products that are designed for use at grade. So you kind of terminate it that way. Why the overhang of the metal coping at the back of the parapet detail? The overhang on the metal coping at the back of the parapet detail, essentially we just don't want any water running down the face of any material, and that's more of a sort of recommendation than a requirement. We definitely insist on the overhang over the face of the stone veneer itself, but it's not necessarily required to have overhang at the back of your parapet wall. But what you do want to make sure is, if you're specifying a metal coping at the top of your parapet wall, that you have slope back to the roof itself and that it kind of slopes away from the face of the building. Isn't the performance of WRB going to be adversely affected by 6-inch on center attachment of the wire mesh? Precisely my point. And this is something that you know, I kind of argue with people a lot on. Not argue, but WRB, these types of WRB that have to be actually fastened to the substrate. I hear you. You're kind of defeating the purpose of it by actually poking a bunch of holes in it. In those types of applications where that is a concern, I would definitely recommend going with a fluid applied membrane, and you may want to consider utilizing the thin set method over scratch and lath. Some types of WRB will recommend that screws are used, and this really depends on the manufacturer. And the difference, what I've been told between a screw and a nail is that in these instances, the screws basically bring some of the material into the hole. And there are some types of WRB that are considered sort of self-sealing. And apparently it basically prevents any kind of WRB system from being compromised by having fasteners go through it. I would definitely recommend, if this is a concern or it's a commercial application, utilize the thin set method, as that won't be an issue anymore. Can you have a printout of the presentation? Absolutely. I would just say follow up with Glen-Gery Events and we'd be happy to get you anything that you might need. Question for Thin Brick. Almost everything I touched on in this seminar can also be applied to Thin Brick. It's really, and everything I showed, every detail, just get rid of the stone, insert Thin Brick. All of these practices apply to Thin Brick and really any thin masonry veneer unit. What about installing stone on a wall over a sloped roof, such as a porch roof? Should this be avoided? I don't see why, as long as you're following all the proper details for terminating the stone and that you have the proper flashing and you have a weep screed at the base. I don't see why that would be a problem as long as it's properly detailed. Normal thickness for stone veneer, that varies depending on the product. There's not so much a prescriptive thickness so much as it's governed by the weight of the units. So as I mentioned early on in the presentation, any kind of thin adhered veneer has to be 15 pounds per square foot or less. So in a lot of cases, due to the sort of non-uniformity of stone veneer units themselves, that thickness can really vary, but it's generally just more governed by weight than anything. I would say if you have some sort of constraint where a specific thickness is required, that you speak to the particular manufacturer and they can give you sort of what I would consider a representative average of how thick the individual units are based on the specific product. You're most welcome, Roberto, for the presentation. How high can stone go without popping out during cold weather conditions? You're not so much limited by height so much as the detailing. So all the detailing that I showed in the previous slides is centered around construction being done in environments where it does get very cold for at least, part of the year. So as long as you're detailing your wall properly, you have proper bond from your units themselves back to the substrate, and all the proper underlayment and WRB is in place, all these assemblies can really hold up over time, regardless of the weather conditions in your locality. Vito, you think you know the answer, but is there any way to detail the stone to go below grade? What I like to tell people is, and again, this is something I run into all the time. People want to run it below grade. If you want to run it below grade, I'm fine with that. And I understand why you're doing it. What you may want to consider doing in those cases is you're going to avoid any kind of manufacturer warranty. They're going to tell you basically, hey, it may be fine, it may not. What tends to happen in below grade applications is the units themselves become ultra saturated, and when they can't dry out and they can't breathe, you can run into problems with deterioration. So one thing I've recommended to people if they want to run stone below grade is incorporating some sort of gravel backfill in and around the stone itself, because this will create somewhat of a French drain effect and prevent water from basically hanging up against that stone. So if you incorporate some sort of gravel backfill, I would say you're going to get those units to last a lot longer below grade. I hope that answers your question. Okay.
All right, looks like Q&A is over. Thank you, Jeff, for today's presentation. Just a reminder to everybody, you will be receiving your certificate of completion by the end of this week. There will also be a link on that to the webinar, so no print-off materials, but you'll have a link to the recorded session from today. And please remember to join us for our next webinar of our series, Designing with Glazed Brick for Style and Performance, on March 24th, same time, 12 p.m. CST and 1 p.m. EST. If that is all, I hope everybody has a great day.
Thanks, everybody.